In this lesson, we are discussing real-world modeling. Our objectives are to model a real-life linear situation with an equation and a graph, and to be able to find the domain and range of a real-life linear situation. Here is our first example. Please remember that you can pause the video to write down the example. The current temperature of the water is 50 degrees Fahrenheit. You are heating the water on the stove and the temperature is rising 20 degrees every minute. Let X represent the number of minutes and Y represent the temperature of the water. We are going to be writing our equations in function form, which is slope-intercept form. So we'll start with Y, which would be the temperature of our water, and that equals, let's take a look at our problem one more time. The current temperature of the water is 50 degrees. Current temperature, that means that 50 degrees is going to be our starting point. Then it says you're heating the water on the stove and the temperature is rising, which would indicate it's positive, 20 degrees every minute. That's our rate of change, and if you recall, rate of change is our slope. So our slope is a positive 20, and our y-intercept is our starting value, and that is at positive 50. Now we're going to create a table of values of 5 points for this particular situation. So we have our x and our y values, which is our f of x. If we start at 0, meaning that we haven't started really heating the water, the current temperature was at 50 degrees. If I plug 0 into my equation, 0 times 20 is 0, plus 50 is 50. Then what happens after 1 minute, 2 minutes, 3 minutes, and 4 minutes? So if I take my x value and I plug 1 in, 20 times 1 is 20, plus 50 would mean that after 1 minute, the temperature of my water is 70 degrees. If I now substitute in 2 for my x value, after 2 minutes, 2 times 20 is 40, and 40 plus 50 means the temperature of my water is 90 degrees after 2 minutes. Now I'm going to substitute a 3 in. 20 times 3 would be 60, plus 50. After 3 minutes, I'm at 110 degrees. If I substitute 4 into my equation, 20 times 4 is 80, and 80 plus 50 would be 130. After 4 minutes, the temperature is 130 degrees. Now, are there any values that are not in your domain? Remember, my domain is my x values. Well, something that's interesting is we probably wouldn't use any negative values because we wouldn't have negative time. So, are there any values not in the domain? Yes. We wouldn't use negative numbers. So we want no negative numbers because our time is positive. Are there any values that are not in the range? If so, explain. Well, if we start at 0 and our time is increasing, we can also see that our y values are increasing. And again, we wouldn't have temperatures that are below 0. So, are there any values not in the range? Yes. We would have any values that are greater than or equal to 50. So, our range is going to be values that are greater than or equal to 50. We won't use anything that's less than 50. When we would graph then, we would use only values in the first quadrant. We don't need to use the other 3 quadrants because those would have negative values. And when we would graph, we would use our x-axis as being values 0, 1, 2, 3, 4, etc. And our y value is our temperature, and we also may need to change and not go by ones, but change the scale so that we could fit all the values on. Here's our next example. You can have 16 gallons of gas in your car. While driving on the highway, your car burns a gallon every 30 miles. Let X represent the number of miles you have driven and Y represent the amount of gas that is left in the tank of the car. Let's begin by finding out what our starting point is, which is our y-intercept. You have 16 gallons of gas in the car. 16 gallons represents the starting point, or our y-intercept. So we have y equals, I'm going to move over just a bit till we find our slope, but we're starting with 16 gallons of gas in the car. While driving down the highway, your car burns a gallon every 30 miles. Every 30 miles. So let X represent the number of miles you have driven and Y represent the amount of gas. First of all, if you're using gas, and our gas then is going to be less for every mile that we drive. To show that, we're going to use a negative value for our slope, meaning that our rate is going to be going down for every mile. And if we burn a gallon of gas every 30 miles, we're going to burn 1 gallon for every 30 miles. That means if I go 1 mile, I have burned 1/30th of a gallon. So that's going to be our slope. For every 1 mile, we're going to burn 1/30th of a gallon. So we're going to create our table of values. And if we start, again, we're not going to use negative values in this problem because in our world we don't have negative miles. So let's start with 0. If I don't drive anywhere and I plug 0 into my equation, I still have 16 gallons of gas left in my car. Now, like we talked about in a previous lesson, if we would prefer not to have fractions, we can use values that are multiples of our denominator. Our denominator of our fraction is 30, so let's use multiples of 30. 30, 60, 90, 120. Now see if this makes sense to you. If I take the 30 and substitute it in for x, I have negative 1/30th. I'm going to multiply by 30, which is 30 over 1. And then I add my 16. Negative 1 times 30 is negative 30 over 30 times 1, which is 30. So I have negative 30 over 30, which is negative 1, plus 16 is 15. Well, that makes sense to me because for every 30 miles, I burn 1 gallon of gas. You may now plug in the 60, substitute in the 60, or realize that if I drive another 30 miles, I will have used another gallon of gas. And so on. Another gallon of gas, and another gallon of gas. Or, if it's easier for you to understand, to substitute the 60, the 90, and the 120 into the equation and do the mathematics. Are there any values that are not in the domain? Yes. We are not using negative numbers because the negative numbers would not exist when we are talking about the number of miles driven. All of our domain will either be 0 or positive values. Are there any values that are not in your range? Yes. Well, our range needs to be less than 16, but we also have to remember that our range is going to stop at a certain point as well. We have to stop at 0 because then we won't have any gas left in our tank and we can't use the negative numbers. So our range are going to be all the values that are between 0 and 16. Our range or our y values are going to be between 0 and 16. When we graph, again we will use only the first quadrant, meaning where all the positive values are located. We won't need to use quadrants 2, 3, and 4 because we will have negative values. And remember that we need to stop at 0 when we're making our graph because once we have 0 gallons, we don't have anything left in our tank. Let's review. Remember that y equals mx plus b is our function form, or the equation we're using for real-world modeling, where m is our slope, our rate of change, and b, our y-intercept, is the starting value. Be sure to check your domain and range, and to complete the reflection.